So today we are doing the last notes for chapter 4 and actually the last notes for this semester as well. So solving application problems with logs. So we have the value of a $100,000 x-ray machine depreciates 5% a year. Write a function for the value of the machine after x years. So remember, we just need its initial value and whatever the rate is, whether it's increasing or decreasing. So what is the initial value of this x-ray machine? $100,000. So that goes in for our initial value. Now it is depreciating. So remember, when something's depreciating, it's going down. Okay? So if we take 100 minus 5, we get 95%. And then we have to change that to a decimal. So it's 0.95. Okay? And since this is a geometric or exponential problem, we raise it to the x. So for the first part, all we have to do is how much will it be worth in 4 years? Okay, so what are we dealing with? We're dealing with our x value. So we know our x value is 4. So we just plug into the equation. F of 4 is equal to that 100,000 times that 0.95 raised to the 4th. So let's go ahead and do that in Desmos. Okay, so we have 100,000, parentheses, 0.95, raised to, remember, is this A to the B button, 4th. And there we have our answer of $81,450.62, but there's a 5, so we're going to round it to 63 cents. And that is our answer right here, $81,450.63. Now, when will the machine be worth $10,000? So we used to guess and check on this. Now we can use logs in order to solve. So we want our f of x to be $10,000. So we're going to go ahead and plug that in. So $10,000 is equal to our initial value of 100,000 times our multiplier, our rate, 0.95, raised to the x. So for this problem, what we want to do first is we want to isolate that 0.95 raised to the x. And we do that by dividing out our 100,000. So we take our 10,000 and we divide it by the 100,000. And that's going to equal our 0.95 raised to the x. So we can cancel out our zeros, right? So all those zeros cancel. So you're left with 1 over 10, and 1 over 10 simplifies down to 0.1. So you can go ahead and do that in Desmos if you want to. So now we have 0.1 is equal to 0.95 raised to the x. So remember, the point of logs is being able to solve for our variable in the exponent. So if we change this to log form, our base is that 0.95. So we do log of base 0.95. Remember, 0.95 and x were on the same sides when it was in exponential form, so in log form they move to other sides. So our x moves over here to the right of the equal sign, and our 0.1 goes here. So now we're going to just plug this into Desmos. Log of base 0.95 of 0.1. So remember, you're using the log with a little a button. So log base 0.95, arrow into that parentheses of 0.1, and there we have our answer of 44.89. So we could round that to 44.9, or we can also just go ahead and make it 45 years. And that's all for today.